This presentation is an introduction of the RP124. It is a 100 mA LDO regulator with a unique integrated battery voltage monitor to make it possible to measure the remaining charge left in the battery. The regulator features an ultra-low current consumption of only 0.3 microamp at no load, extending lifetime of battery-powered devices. Specific applications are mainly in a sleep mode and only wake up briefly to perform a measurement. They transmit some data and go back to the sleep mode again. So actually the sleep mode is the dominating operating mode, and it is necessary to reduce the current consumption in this mode as much as possible. The RP124 fits perfectly in such a requirement with its current consumption of only 0.3 microamp. On this slide we compare the battery lifetime when using a general LDO with 1 microamp and the RP124 with 0.3 microamp current consumption. Specifications of the measurements are shown below the graph on the right. The results are shown on the left. For a 100-minute standby time, the RP124 achieves 2.5 times longer battery life compared to using a general LDO. Based on this result, it is also possible to downsize the required battery capacity when using the RP124 to achieve the same battery lifetime. The additional battery monitor circuit is one of the key features of the RP124. A conventional way to measure the remaining battery charge is using an external resistor divider plus MOSFET connected to an analog to digital converter. See the illustration on the left. However, the input impedance of the analog to digital converter is typically low, and the resistor divider impedance should be low as well, resulting in a considerable current flow to ground. It is draining the battery and limiting the lifetime of the application. The RP124 provides a simple solution with a built-in resistor divider and voltage follower as a buffer. See the illustration on the right. This circuit has a much lower current flow to ground, and the BM output is compatible with the input impedance of the analog to digital converter. Additionally, all essential components for this circuit are integrated into the chip, reducing valuable circuit board space and cost. In this way, it is possible to make a simple fuel gauge for primary batteries, for example. This slide shows an example of how to use the battery monitor. One can compose a simple 3-stage fuel gauge to measure the remaining charge left in a coin-type battery. The battery voltage is used to indicate the 3 stages of the battery and advises to replace or charge the battery as soon the voltage reaches its lowest level. The RP124 is a special kind of product offering 3 operating modes for the LDO. Mode 1, low power consumption mode, saving battery power as much as possible. Mode 2, fast transient response mode, operating with an enhanced dynamic performance. Mode 3, off mode, to reduce current consumption to a minimum and controlled by the chip enable pin. The device switches automatically between the low power consumption and the fast transient response mode. It is controlled by the output current demand of the application. See the illustration on the left. Note that a hysteresis is built in to prevent an oscillating effect when the current demand is exactly at the switching threshold. The ripple rejection performance of the LDO is enhanced in fast transient response mode. Refer to the graph on the right to compare the results for various output currents. On this slide we would like to demonstrate the response speed when an input transient occurs. The left illustration shows the LDO in low power mode as the output current demand is only 100 microamp. Note that the response speed is low and large peaks may occur on the output voltage. The illustration on the right shows the LDO in fast transient mode as the output current demand is now 30 mA. As a result, the response speed is fast and only small peaks occur on the output voltage. Another slide to demonstrate the response speed when a load current occurs on the output. The left illustration shows the LDO performance in low power mode when the output current demand increases from 1 microamp to 10 milliamp. Note that the response speed is low and large peaks may occur on the output voltage. The illustration on the right shows the LDO in fast transient mode, and the output current now increases from 1.5 milliamp to 10 milliamp. As a result, the response speed is fast and only small peaks occur on the output voltage. This is the actual circuit diagram of the RP124. It is a simple circuit and requires only a few external components, like small ceramic capacitors for the input and output of the voltage regulator and the battery monitor output. The RP124 has input voltage range from 1.7 to 5.5 volt. This is the recommended operating voltage range. The output voltage is internally fixed and can be set from 1.2 to 3.6 volt and has an accuracy level of 0.8%. Maximum output current is 100 milliamp. As for the battery monitor, one can select from two product versions with a divider ratio of 3 or 4. Other options are which circuit is controlled by the chip enable pin. It can be either the LDO or the battery monitor. Note that in case the battery monitor is disabled, the total current consumption will decrease to 0.2 microamp. Also, one can select a version with or without auto discharge function for the output capacitors when the LDO is disabled.